Hey, welcome to Chapter 4. Congratulations on finishing up the test for Chapter 3. We're going to be looking at more linear equations and inequalities. We're going to find ourselves looking at different ways to approach problems, what kind of patterns there might be, when we might have equivalency, and what does that mean. As you can see from the contents, we've got a few lessons to go through, 1 through 9. The first opening here talks about a light bulb manufacturer producing two kinds of bulbs, regular bulbs and new compact fluorescent bulbs. Read through it. As you know, you should read all of the book. And we come to some representations for it. We've talked about these before, where the table is the arithmetic relationship, the graph is our geometric relationship, and then finally we use equations to get an algebraic relationship. Depending on what we want, one or the other or all of these might be needed. A graph is a good approach when an approximation is okay. If we're just going to get to kind of a close enough value where they cross over, then we'd say, pick a number. It's more than 450. Is it 460? I don't know, maybe. So we might say around, somewhat greater than 460 hours, or anything greater than 460, something to that effect. When we look into this table, we can see that where we have the change occur is somewhere between 500 and 600. And then finally, we're looking at the equations we can write about the inequalities for the different situations, and finally the equivalency statement when they are the same, which is where the two lines intersect. So we've got various representations we can look at. We'll begin with percentages. Okay, this is 4-1, solving percent problems using an equation. We want to remember that when we're working with percentages, that percent means per centum or per 100. So when we write something, like here we have this 7%, that is equivalent to 7 divided by 100, or 7 per 100. It's also equivalent to 0.07, which is 7/100ths. 7% is not a useful algebraic form. We need to convert it either into a fraction or into a decimal if we're going to use it in an algebra equation. Otherwise, we run into some kind of odd things that could happen when we use a percentage like that. So taking a look here at the lesson, we've got how to solve these kind of problems. And if we want to know what 7% is of something, it's basically 7% of what number is 91. So what we're asking here is 0.07, this form, times the number, which is question or in or whatever you want to use, and the result is 91. So we're not looking at what is 7% of 91. We're not trying to find that out. We're trying to find this other one. So then we go ahead and divide 91 by 0.07. We get that Q is equal to 1,300. We can plug it back in and check it. So the formula is really pretty easy. The percent of a given quantity is equal to R. And so we got P times Q equals R. And that's the resulting quantity. And that gives us a form we can work with. Example 2, what percent of 160 is 38.4? In this case, we don't know what P is. You know what Q and R are. And so you solve it for that. And I'll go through some other examples here with you in just a minute. And then our last example is a tip problem. Now, this is something that can happen not uncommonly. If we want to know the total cost of a meal, if they say there's going to be a tip added, there's going to be a tip added, and you want to know what that's going to be. We know that we know the cost of the meal. but the total cost is equal to the cost of the meal plus the cost of the tip. So what's the total cost going to be? It's going to be the 100% of the meal cost plus the tip, which is 18% of M. We add those together and we get our final cost, which would be 4307. They use the distributive property to have that M is multiplied times both of these, so 100% plus 18% is 118%. At this point, they elected to rewrite it into algebraic form, into decimal form, so 118% is 1.18, and we did our calculation, got our result. If we'd multiplied this by 118, we would have had a far different number here. That would have been a real expensive meal. And then our other case is we just simply find the tip, add it to the cost of the meal, and away we go. Not much different in results, but different approach. Guided example 4. This uses the distributive property. A dishwasher normally costs $320 but is on sale for 15% off. What is the sale price? This is a discount kind of problem. This is one that I've noticed over the years that can be a little bit troubling for students. A couple of things that shouldn't happen here when you're doing these kind of discount problems is, one, you shouldn't find that the cost you get on sale is greater than the original cost, because that's not going to happen, right? I mean, it's on sale. You're not going to pay more for it. The other thing that shouldn't happen is that you should not have something really, really tiny. So here's what could happen is you calculate your 15%, you determine that that's what you're going to pay. Well, that's a really small number. So think about this problem. Let's say you want to go buy some shoes, and the shoes cost $100. Okay, they're Katy Perry shoes, of course. Really nice, cool Katy Perry shoes. $100. But now they're 10% off. Are you going to pay $10 for them? No, you know that. It's not going to happen. So the 10% off is 10% of the price deducted from the original price. So 10% of 100 is $10. 100 minus 10 is 90. You'll get your marvelous Katy Perry shoes for merely $90. So let's look at this particular one. The sale price, we got P is B, the regular price. The discount is 15% times P, or 0.15p. So the sale price, we'll call that S, is equal to the regular price, P. Now we have to take away, minus the discount. And the discount is our percentage. It was 15% off. So 0.15 is 15%, right? 15 per 100. Move the decimal point. You forgot that already? 15%, right? That means I'm going to move a decimal point over from here, 2 places, so it's 0.15. So it's 15 hundredths. 15 100ths. 15 100ths. So S equals the original price minus 15 100ths times the original price. That's going to give us the discount. Now we can use the distributive property. This is just 1P. P times 1. So this is S equals P times 1 minus 0.15. And if we combine the like terms, we see we get S is equal to, that's 1 minus 0.15 is 0.85 times P, 0.85 times P. And so my sale price is going to be 85 hundredths of the original price. Now, what was the original price? The original cost was $320. So S is equal to 0.85 times 320. And S is equal to, let me grab my calculator, 0.85 times 320 equals $272. So our sale price is $272, a reasonable amount of discount, and we can get on from there. So that's guided example 4. I'm going to go back through a few other examples from the book and hope they can help you out. Okay, we're on to some extra examples for 4-1, the percent problems. Let's take a look at our first one here. We've got 4% of what number is 76? And remember, we had our form of this, which was the, let's see, P times the quantity is equal to the resultant quantity. So our percentage times the quantity equals R. And so 4% of what number? So this is our P. What number is Q, and is 76, that's our equal sign, is R. So that's saying 4% times Q equals 76. Now 4%, as I mentioned, is not a useful algebraic term. It means 4 per 100. I'm going to move the decimal point over 2 places. I'm going to get 0, there's my decimal point, 0, 4 100ths times Q equals 76. Now I've got a real straightforward problem. I'm going to divide both sides of the equation by 0.04, and so I've got 0.04 Q over 0.04 equals 76 over 0.04, and Q will be equal to, because that's 1 right there, right? 1. And let's see what this comes out to be. 76 divided by 0.04 equals 1,900. 1,900. So 76 is 4% of 1,900. This is our answer to the first question. Let's go ahead, we'll take a look at our next one. And this one is, what percent of 210 is 33.6? So let's see, this is our P, this is our Q, and that's our R. Is our equal sign. So what I don't know is the P. So P times 210 equals 33.6. Now, pretty straightforward. I take the reciprocal of 210 and multiply that times both sides, or if you like, I divide both sides by 210. So 1 over 210 times P times 210 equals 33.6 times 1 over 210. These are going to cancel. So I just get that P is equal to, well, let's see what we get here. .16. Okay, are we done? Well, not quite, because it asks for the percent. It's not asking for the decimal. So I have to convert this to percent. So P equals, and this is per 100, so that's 16 100ths. So that's equal to 16 over 100. And so that would be 16% or 16 percentum, 16%. Move the decimal place 2 places. We've got our percent. Here is our requested answer. This is our intermediate one. Okay, let's take a look at the next one. I hope this is going well for you. Just keep in mind your formula. Now here we've got a discount problem. Oh, not a discount, sorry, it's an extra cost problem. Dawson wants to buy a pair of jeans costing $44.50. He knows he will be charged 4.5% sales tax on the jeans. Find the total cost of the jeans, including the sales tax. Well, what's that going to be? This is where we have to add some value in. We've got the original cost of the jeans, which is $44.50. So $44.50. Plus, he's going to be charged the tax plus the cost of the jeans. It's not just the tax, right? So he's got this 4.5%. Now I can't use 4.5%. I need to convert that to a decimal form, and I need to move my decimal place 2 decimal places to the left. So that's going to be 0.045 or 45 hundredths. And that's times my original amount, which is $44.50. And that's going to equal his total cost. We'll make that T. So now we just got to do the calculation. We've got the setup, so 0.045. And we get that T is equal to 46.50. So what I did was just multiply the 0.045 times 44.5 and then added 44.5. What I could have done if I was smart was add these together, because I have this 0.045 and times 44.5 and 1 times 44.5. So let's see, I'm going to take out the 44.50 parentheses, and that's 1 plus 0.045. The original cost is a 1. My tax cost is the 0.045, and that's equal to my total, because the 44.50 was common to both of those. Now I can add those together and just do one multiplication of 44.50 times 1.045, which is going to equal my total. And so 44.50 times 1.045, and that gives me $46.50. Now you'll notice from the calculation that we had some additional terms. We're not going to round that up in this case. We would have to we would round down versus round up, because the term after the hundredths place is less than 5. If it was 5, we would have to figure out which way to go to round it. If it was greater than 5, we would certainly round up. But it would depend on what's happened with that. But the correct way to round this was to 4650, not 4651. We have our solution. And Dawson has his genes. Lastly, we've got a discounting problem. And this is this typical sale price problem. It's on sale for 20% off. What is the sale price? Now, if it's on sale for 20% off, that's a discount. So that, unlike taxes where we added it to the price, we're going to find something where we're going to be subtracting it from it. And that's our original cost was $425. That's the original price. And we're going to deduct from that our discount. And our discount is 20% off, and it's 20% off of $425. And so we want to find out what is 20% of $425. We need to change this to a decimal. So we've got 0.2. Move the decimal point 2 places, right? Times 425, and that's going to give us the sale price. Again, using the distributive property, we have that it's 425 times 1, the regular price, minus the whole price, minus the discount, which is 0.2, and so that's going to give me 425 times 1 minus 0.2 is going to be 0.8. So 80 hundredths is equal to S. So 81 hundredths is our value that we have there, and we're just going to go ahead and do the multiplication. 425 times 0.8 equals 340 is our bargain for a new bicycle. 340 is the sale price. Now again, be careful with this, because there's one of the things I find that often happens is a student will take the 20%, and let's see, and they'll go 0.2 times 425, and that equals 0.2 times 425 equals $85. And they'll conclude that they're going to get this bike for $85. Now, I challenge you to consider that from a street sense, and I know you guys are street smart. Well, maybe you're not street smart, but you sure are mall smart. You know what you're going to pay for things. You have a good sense of what the cost is going to be. You know you're not buying a $425 bicycle for $85, not in a store. Okay, it's not going to happen. And you're going to find these kind of problems give you reasonable responses. So be aware of that kind of an error and don't be making that mistake. That's right here. This is the error of saying, well, I've got my discount, $85, and that's what I'm going to pay. No, the $85 is what you're saving and what will be deducted from the $425. So that's the amount of savings, not the amount that you would pay. You're going to pay $340. Okay, that's it for 4-1. I hope this was helpful. Again, read the lesson, go through the other examples, do the covering the ideas and applying the mathematics, prepare for the mastery quiz. Let me know when you're ready. Thanks a lot. Be talking to you soon.